My name is Chang.
My name is Kelsey Jarecki. This is Lab 8, the laser.
And our TA is Susanna.
So this experiment was to explore aligning a laser and transverse modes. We did this by using this green laser, shining it into this gas tube, and then adjusting this tip tilt mirror so that the light would go directly back into the gas tube. We turned on the gas tube and adjusted the tip tilt mirror. The transverse modes would appear. This is the most we could get. It is TEM 43. So this gas tube has a slanted glass with a refractive index of 1.5. Find the Brewster's angle, which is 56.3. Only P-polarized light is transmitted.
Okay, for this part of lab, we investigate the longitudinal mode spacing using 3 methods. And here is the setup. We have the laser, the beam splitter, the detector which connect to the ESA, and also this Fabry parade connected with the oscilloscope. So we first physically measure the length of laser cavity using a ruler, and then use this equation to calculate the mode spacing. This is what we got from the electrical spectrum analyzer. Then we use the Fabry parade to measure the spacing between the modes, and here from the oscilloscope we can see 2 peaks, and they represent different modes. They are periodically repeating. Here is a little drawing which represents what we have from the oscilloscope. We use the cursor to measure the reputational time spacing and also the mode time spacing, and here is how we do the calculation.
We can back calculate the length of the laser cavity. Using the ESA, we found that the laser cavity is 34.2 centimeters, which is 11% smaller than the physical measurement.
For this part of the lab, our goal is to measure the divergence angle of the Payne laser. Because the output can be regarded as the Gaussian beam, we could also calculate the beam width and also the numerical aperture. And here is the setup. By sliding the detector, we can change the distance between the detector and the laser. We could measure the XY diameter and take the average.
We found the radius, squared it, plotted it against the z. We used the coefficient from the x-squared term of the polynomial equation to calculate the beam waist, W0, and then use that to calculate the Rayleigh range, which is ZR. Then we use both of those to calculate the divergence angle, and then use the divergence angle to calculate the numerical aperture.